Additional facts. Ohm's law is one of the most useful equations in electronics, but it's important to understand that it's not a universal law. It only applies to ohmic materials, meaning materials where the relationship between voltage current stays consistent. Many real-world components like diodes, transistors, LEDs, and even heated wires do not follow Ohm's law. Additional facts. Ohm's law is one of the most useful equations in electronics, but it's important to understand that it's not a universal law. It only applies to ohmic materials, meaning materials where the relationship between voltage current stays consistent. Many real-world components like diodes, transistors, LEDs, and even heated wires do not follow Ohm's law. Additional student interest described. Personally, while creating this project, I've learned new things I knew absolutely nothing about. Something that stuck out to me the most is that I learned most electronics wouldn't work without Ohm's law guiding how their circuits are built. Once I understood how voltage, current, and resistance affect each other, the problems finally started clicking for me.
Additional facts about Ohm's law. Something that I found interesting is Ohm's law is actually one of the first formulas students had to learn about electronics. Other works of George Ohm. He studied the relationships between heat and electricity. He helped build early ideas that led towards thermodynamics. Later in life, he became a physics professor and taught mathematics and engineering. Other scientists that were connected to Ohm's law discovery, Andre Marie Ampere, he discovered the relationship between electricity and magnetism. His work and Ohm's law together formed the base of circuit theory. Other things people should know is Ohm's law only applies to materials that are ohmic, meaning their resistance stays the same. Additional student interest. Interesting facts about Ohm's law. NASA used Ohm's law when designing spacecraft electric systems. Also, learning that Ohm's law was rejected by many different scientists who George Ohm first published it. Many of them thought it was too simple. I think what needs more investigation is how the role of Ohm's law and medical equipment, especially imaging machines and heart monitors. The overall summary of Ohm's law. Overview on how it went. I think this project was overall different and a bit complex. The research project gave me a lot of insight about electricity and how it works in the medical field. The most surprising thing to me about Ohm's law is I learned how much Ohm's law is used in our everyday life. I didn't expect medical machines and equipment to be used. The earliest and hardest parts about Ohm's law is it was how to use the formulas and writing the definitions of the components. The hardest part is creating a brand new and original problem, not from a textbook. The most important part of Ohm's law is how to apply it, not just memorizing it. And relevant sources is Ohm's Law, Klein Academy.
An interesting fact is that Ohm's law, which states the voltage equals current times resistance, is not a simple formula but a fundamental principle that applies to many electrical circuits. But it only holds true for ohmic materials, those that have a constant resistance regardless of voltage or current. Non-ohmic materials like transistors don't follow this law. When I first started researching, I thought Ohm's law was just about memorizing a formula to solve basic circuit problems. But I learned it's actually a gateway to understanding how electricity behaves in real-world materials and devices, and is crucial for designing everything from household wiring to complex electronics. If I had more time and resources, I'd love to investigate how temperature affects resistance in different materials, since resistance can change dramatically with heat. Also, exploring the behavior of non-ohmic components under varying conditions would be fascinating, especially how they deviate from Ohm's law and what that means for circuit design.